Welcome back. Today we review Llama 3.1. We'll take a quick look at the key takeaways, benchmarks, and interesting design choices made by Meta for this epic release. Let's go. Let's directly dive into the key takeaways. Llama 3.1 introduces a huge 405 billion parameters model together with an 80 billion and 8 billion models. They expanded the context window to 128k tokens, and they now support 8 different languages: English, German, Spanish, French, Italian, Portuguese, Polish, and Dutch. They trained on 15 trillion tokens compared to 2 trillion for Llama 2, over 16k H100 GPUs for a cumulated 39.3 million GPU hours. That is huge. They have a more permissive license, which now allows improving other models using outputs from Llama 3.1. They also provide quantized version of the models up to 8 bits and 16 bits. They trained on data up until December 2023, and they launched with many partners including AWS, Nvidia, and Google Cloud, among many others. We can already tell that Llama 3.1 is a beast and a good news for the open source community. But how does it compare to the competition, especially closed source models, on popular benchmarks? We have 7 main categories of benchmarks: general knowledge, code, math, reasoning, tool use, long context, and multilingual. On the left you can see benchmark for the Llama 3.1 405 billion models, and on the right for the 8 billion and 70 billion models. For every row you see highlighted the model that performs the best for a given benchmark. As we can see for the 405 billion model, it is on par or even beating the competition in many benchmarks, making the model quite comparable to GPT-4, Claude, or GPT-4 Omni. Now, if we move on to the 8 billion and 70 billion models, we can see that they beat the competition on the majority of benchmark, making those smaller models more affordable to run on your own machine, quite attractive. So we get an open source model with great capabilities, even competing with the best closed source models like Claude and OpenAI. But how did Meta achieve those results? After reading through the Llama 3.1 paper, I realized that the Meta team made some interesting design choices that I would summarize to architecture simplicity and data quality. Starting with architecture simplicity. They used a decoder-only transformer architecture and avoided the mixture of experts to improve training stability and have a more predictable scaling. They also streamlined the post-training. After training on trillions of tokens, you get a pre-trained model that you need to align to human preferences. A popular way to do it is to use reinforcement learning approach, known as reinforcement learning from human feedback. This is known as complex and relatively unstable, so Meta opted for a simpler, post-training approach that follows a cycle of 3 steps run in multiple rounds. The first step of the cycle is rejection sampling. For a given prompt, they sample multiple generations and use a reward model to build a dataset out of the best ones. Then they use supervised fine-tuning to fine-tune the model on the created dataset. And finally, they use direct preference optimization on a dataset where humans compare output and express preferences instead of fully annotated answers to align the model. After every round of those 3 steps, they use the latest model to start the next round, and so on. So moving on to the data quality, Meta took a specific care in cleaning their data to fit the best quality tokens to their model. It starts first with text extraction from HTML web pages, deduplication at the URL level, document level, or sentence level, heuristic filtering, so those are rule of thumbs to discard bad data like adult content or documents with lots of outliers. They also used models to filter the quality of documents, so various models to assess whether a piece of content is of good quality or bad quality, and finally a specific pipeline to extract code and reasoning data, and using Llama 2, so models from the previous generation, to annotate this data. So by combining architecture simplicity, data quality, and computing power, Meta achieved performances similar to closed source model. which is a point for data-driven development where you spend more time on data, improving the data quality compared to iterating on the model architecture. Though modern LLMs have multimodal capabilities like vision or speech, what about Llama 3.1? The Llama team made experiments to integrate other modalities to the Llama models. They tried on vision and speech, and both follow the same architecture. First, you train an encoder. For vision, it's a vision transformer, and for speech, it's a conformer model. Those encoder gives you embeddings or features representing the modality, either speech or images. Then you have an adapter. It's a model that connects the feature representation to the LLM. This allows the LLM to understand other modalities. However, it's worth noting that Meta is being cautious with the release of those multimodal capabilities. They are still under development and not yet ready for public release. I will finish with a quick note on tooling and legal. Llama 3.1 comes with the Llama Stack API, which includes toolchain APIs and agentic APIs. Llama has the ambitions to become a fully fledged development platform. It also comes with Llama Guards 3 that helps you building content moderation and prompt guards that helps you detect prompt injections. On the legal side, Meta released Llama 3.1 under the Open Model License Agreement. Though there is a specific limitation, if you have above 700 million monthly active users, you need to request a special license from Meta. And finally, there is a license upgrade allowing dev to use outputs from Llama 3.1 to improve other models, which was not the case for previous generations. In conclusion, Llama 3.1 is a crazy release, competing with closed source giant on both performance and capabilities. And whether you're a Meta fan or not, it's undeniable that they've become a major force in open source AI development. Now, if you like this video, give me a sub to help me on the road to 1000 subscribers. See you in the next one.